morning for our distance learners. Everybody is distance there, and Blake is out there with you. We are first going to the board. We can talk about what our homework is, right? We are actually going to work it out problem book. Yay, it's geometry, guys. Yay. We are getting a book. If you ask for a book, I have printed one. If you say you're fine with the electronic version, then thank you for studying it free. Our distance learners, you guys all have a link to the problem book. It's on the homepage of Canvas. I also will put a link to it every time we do problems in the problem book. I will put a link to the problem book right there in the homework. You don't have to go looking for it, okay? You can also bookmark it in your browser. I've got it in my bookmark as well. So in the problem book, we're going to do 1.2. That means page 1, problem number 2. 1.3, page 1, problem number 3. 1.7, page 1, problem number 7. So that's how we'll always number our problems. The first part of the number is the page number. The next number is the number of the problem on the page. Happy it's not Monday day. Today's Tuesday. Woo! So we're going to review our algebra final questions. I'm going to go through the root quiz with you just to make sure we all understand what the answer for to the root quiz is. We're really good on that. Not everyone has taken the Algebra 1 quiz yet. There are some folks who did not do it for the deadline. So I'm not going to go through that and give answers because some folks still haven't done it. And there are a few of you who haven't exhausted all 3 tries and may still want to. So we'll go over that after the 3 tries have gone out, which is not today. We'll probably do that Thursday, Friday. So we'll look at the root quiz. We're going to set a deadline for the algebra work. That will be end of this week. Everything has to be turned in. That includes your Sudoku graphs, the Algebra 1 quiz, all the tries on that, everything has to be done. If it's not done, it's a 0, and I'm not going back to it. If you were working on trying to get updated grade, you got a 2 or a 3 and you wanted a 6, it's got to be done by then. I have to be able to close those out. Today we're going to start talking about geometry. We're going to start problem 1.2, which is what you need to have in your notebook for a grade. And we're going to do 2.3, page 2, number 3. So when I say that this is our homework, 1, 2, 1, 3, and 1, 7, that means that you will do those 3 problems in your notebook and you'll take a picture of them and upload them into Canvas. Today is Tuesday. When do we meet next? So when is this due? 11:59 on Wednesday. So yeah, and actually we got a clarification. The faculty did, sorry, all teachers should be using this now. Other teachers may have been saying day of class or the day before or the day of or whatever. Everyone should be using the same thing. So today is Tuesday. The next thing we need is Thursday. Then that means just do Wednesday. 11:59. Bye, Brooke. Bye, Brooke. Bye. Good luck, Brooke. Did Charlotte have a school? Go eat. Good luck, Brooke. All right. So let's get started. We're going to go back to class 5. All right. Good. I know. Small class. But just think of how many distance learning folks are watching this video with us. With the best people ever in class.
Miss Edwards.
Yeah.
I can barely hear you. I can hear every other word.
I'm sorry. So you'll probably be able to hear me now. Is it better now?
Yeah, a little bit.
Yeah, because my microphone is here at the desk.
Mm-hmm.
So now that you can hear me.
Yeah.
I'm going to take a picture of the board, Blake, and I'll upload that into Canvas as soon as class is over.
Mm-hmm.
you'll be able to see everything that I just talked about over
Okay.
the board. And then the link to this recording will also be in Canvas. So that's how all the distance learners will find it.
Mhm.
So let me share screen. The first thing we're going to do is review the roots quiz. A lot of people did really well on that.
On the algebra quiz, I promise you, I wasn't trying to be like, oh, see, I put the wrong button or whatever, but on one of them, I put 59. And then somehow it said 5,940. Oh, so.
I saw that and I thought that's strange.
Because I don't know if I was just not paying attention to the next year. I wanted to put 40, but I checked to see if the next year had anything on it, and it did. But I don't remember.
I saw that.
This was 59.
I'll fix it. I'll fix it for you, maybe. All right. Oh, so somebody hit the down button on the screen and we'll all look at it together. It's underneath the light bulb, the well, on the left, Hannah, the left, your other left. There you go.
Miss Edwards, guess what?
What?
I'm getting her today on Saturday.
You're getting banged?
Not like disgusting, but like
Yes. I do that every once in a while. I'll get a few bangs. Okay, so we're looking at the square roots quiz. And in Canvas, in the teacher view, in Canvas, it lets me go in. You can see that it is published, which means students can see it. It could let me edit it. If I click this button that says edit, it will say, whoa, people have started taking this quiz. Are you sure you really want to do that? And I wouldn't. But if I preview it, what it will allow me to do is actually take the quiz. So let's take the quiz and solve these questions and make sure everyone understands roots. So the first one says simplify square root of 80. Now remember, when we're simplifying square roots, we're just factoring those numbers. Factor those numbers under the square root sign, and we're looking for perfect squares. Is 80 a perfect square?
no.
No. Does it have a perfect square in its factors?
Yeah.
It does. What's a perfect square in its factor? 4, yeah. So 80 is 4 times what? 4 times 20. Yep.
Yeah.
And does 20 factor
Yeah.
into what? 5 times 4. We actually have 2 4s. No.
No, you have 4 outside the square 5.
No.
Yes.
So I'm really, oh, yes, you're right.
Yeah.
Just kidding. I was testing you. Testing you, Hannah. Just testing. Yes. Yes. So make sure that whatever you can't factor any further stays under the root sign. So the 5 has to stay under the root sign. The perfect square, we had 4 times 4. So that's 16 we had underneath. And the square root sign undoes the perfect square. So 4 does come out. 4 times 4 underneath is a 4 on the outside. So it is 4 root 5, not 2 root 5, which is what I was about to say.
The one that you have the double number goes on the outside.
Yeah. The double number goes on the outside. Okay, this one, the square root of the fraction 100 over 121.
And you'll usually like when it's 10 over 11 under it, and if it's a perfect square, that gets rid of it on one side, and if it doesn't factor out on one of them, it's still.
Yes, if it's a perfect square, the root goes away. If it's not a perfect square, then that symbol stays. So in this case, what happened?
then I'm like, I can't believe the last set of my grades in Spanish. Making blocks. That's one of their
It's what we're learning about. 100 over 121.
11, I'm that's number 11. 121 is a perfect square, so that's 11 on the bottom, and then 100 is a perfect square. Not a perfect square. It is a perfect.
So
10
is
times
it-
10.
Is
So
it
that's
number?
10 over 11.
Is it number 2 or number 3 though?
Number 10 was that.
No.
Oh.
Square root of 10 over
It's
square
number
root.
3.
It's number 3. That's right.
I got a 50 on this, but now I know the answers. I got it, y'all.
Okay, so number 3 was a little oopsie for me. This is simplify the square root of 5 over 7. Can you simplify that at all? No. 5 over 7, according to what we've done so far, you cannot simplify at all. Now, there's a thing called rationalizing the denominator, and we have not learned how to do that yet. But essentially what you do is look at the denominator, the bottom part of the fraction, and you multiply the top and bottom of the fraction by that number. So we would multiply the top and bottom by the square root of 7.
Which is 7 with the square root.
So yeah, on top it would be 7 times 5 under the root sign. On bottom it would be square root of 7 times the square root of 7, which is just 7. So the correct answer is square root of 35 over 7. Regardless of what answer you put, you got correct credit for this.
Oh, really?
Yes.
So does that mean I got a 60 or 55?
Whatever you put there, I gave you a point for it. All right. Square root of 13 over 49. Square root of 13 over 49.
It's a 13 with a sign, and then at the bottom is 7.
Yes. We can't break down 13 very far, but the square root of 49 is just a 7 with no square root
Is
sign.
Blake still there?
Blake is still here.
I miss you, Blake. Blake? Hello?
I'll probably be back tomorrow.
There he is. I put him on the screen for you.
Oh, hey, Blake.
All right, we have 5x squared equals 125. This is algebra. How do we get the x squared by itself?
You divide it.
Divide by 5. 125 divided by 5 is 25. So we have x squared equals 25.
Is 5. Where's Winston?
So x is 5. Golf. X is 5. Yeah. X squared is a perfect square, right? It's x times x.
Why is Blake gone? Does he have to go there?
No, I just left my backpack 2 hours away in another city and then forgot to get it.
Not to come to school because
Yeah.
of backpack inconvenience. I think that should be counted as an unexcused absence.
And plus, I was running late because I overslept. So by the time I would have got here, school would have already been over.
That sucks, Blake.
Yeah.
Hey.
Instead, you chose to come to your classes.
Yeah, I
So
came.
to come to his classes virtually, I think it was an excellent decision.
I would have liked to see you here, but oh well. Wait, I want to do the next problem on the board. Annoying.
Okay, it's 2x squared minus 15 equals 65. So it's got some algebra.
This is so hard.
She's adding 15 to both sides,
I
Blake.
think I guessed on this because it looked like too much math. It's one of them. It goes and looks like too much math. Yeah, I just had a lot. That's why I get this.
She's got 2x squared equals 80. She added 15 to both sides. Now she's dividing both sides by 2. So 2x squared equals 80 divided by 2. Now she's got x squared equals 40. Now what's she gonna do?
She gotta divide it by x.
You can't divide by x.
Well, that sucks.
It's x squared, so x is a perfect square. So what do we do with perfect squares?
We cut them in half.
We square root them.
X squared.
We square root them. So we square root the x squared, and then we square root the 40.
So x squared equals squared 40.
The square root of x squared is just x.
And then it's the bottom one.
Yeah, so how do we simplify the square root of 40?
2 times 2 times 10. So that's what it is. That's 4 times 4. 2, but 4 is perfect times the square root of 2. Or square root. That was 2 times 2 times 10. Okay. And then the 2 goes 2 and then 10.
Show your work. What two things multiply to 40?
2, 4, and 10. 4 and 10.
Mhm.
Boom. And then so.
And then what can you take the square root of?
4. And so that's 2 and 2. Yes. 2. I just don't know how. I forget like which order to put them in.
So write it out. You square root of 40 is the square root of 4 times 10.
4 times 10.
And we know the square root of 4 is?
2 times the square root of 10.
There you go.
Oh.
2 times the square root of 10.
Do I get my name on the board?
You worked one problem, Megan.
Hannah got it by just getting paper towels.
She saved us when the ceiling exploded.
I saved y'all, Megan. I thought you screamed. I didn't scream. Charlotte screamed.
Yeah, it could have landed on Charlotte's head.
That would have been funny.
It's nice that it landed between students and not on
X
students.
6. Wait, what's the problem?
Yeah.
Because 7 plus 29 is 36 and 36 is 36. Look at her!
Shebang.
Wow, diggity dogs. Hello.
All right, here we go. 3x squared minus 4 equals 32.
I could have done so good on this quiz if I took it right now. Okay, plus 4, plus 4, 3x squared equals 36. I'll let Megan do the work on this one. Divided by 3, divided by 3, 2 squared, x squared equals, x equals 2 squared. 18.
No,
X.
not 18.
12. What? 36. Oh. My bad. I was thinking of 2. 12. And 4 times 2 times square root.
Yep.
Okay.
So let's see how we did according to, oh, I don't think they'll tell me. I think it doesn't tell me when I see it.
Hey, pledge time.
Woo!
I pledge my word as a love lady that I've never given nor received any aid on this quiz. Any? Never. This is any.
All right.
I never have used any.
Good job, guys.
Oh, me either.
Can I do it? Can I erase this?
Yes, thank you. All right, so
Do you have an open box?
so we talked about Algebra 1 stuff. If you have outstanding graphs or quizzes or anything, you need to have those done as quickly as possible. I've got the Algebra 1 quiz. If you have second or third choice, the chance is still available. Please get those done by Thursday.
I'm gonna need it done today.
Distance learners, I'm going to send you a message and explain to you what you have outstanding and ask you to please get those done as well. You'll have a little bit more time, but I want to make sure that you have connectivity into Canvas. So I will contact you each individually and ask that you respond to my message so that I can be sure that you received it. So now I'm going to ask you to turn to the problem book. And for those of you who are online, you can go to our homepage and click on the problem book, or if you have it saved, as a bookmark. You can just jump straight to it. This is our problem book. And I think you have to go down about 8 pages in the PDF to get to page 1. For those of you hanging out here, I sent a questionnaire to whether you wanted a hard copy
Oh, I said no.
problem
I
book.
said hard copy because I can learn better on paper.
And let's see, Gracie and Kamaya and Megan asked for hard copies. I know that some of you didn't answer, maybe because I sent it to your web email and you didn't even know that you got the option. So if you would like a hard copy,
Yes.
yes.
I feel like I'm gonna need one and I don't know why I didn't ask for one.
So,
It made it sound bad. You said kill the tree. So
yeah, it's literally just a list of problems. It's not a workbook. that
I
you're
feel
gonna
like my
actually-
internet's gonna cut out one day and I'm not gonna have it.
That's a good point.
So are we doing like RCP program?
Yes, you can write in it. Yes. And Blake, I have plenty. So if you want one when you're back, you can have one.
Alrighty, and yeah, can I get a charger for my computer real quick? My computer's about to die.
Yeah, go ahead.
I was about to ask, can I go to the bathroom? Sorry. Oh, but like, no. Wait, we should play a game where we play in this or like
Oh,
I was just math them with me. Did your earrings fall out?
It did. I lost the back to it this morning.
We should. Wait, y'all, what's a math game we used to play? Bro, where you would give us a problem and we have whiteboards and we like write it down real quick and like raise it up.
And the first person to get it wins. And then the person with most points.
Okay,
How about the part where we actually do some geometry out
No,
of this
because we
book?
put up problems and we write them and we solve them.
So we're doing the first one, we're doing 2, 3, and 7.
Yes, we are.
Right now.
But we're gonna do number 2, what did I have? 2,
3. Whoa.
just kidding.
We're doing this like a graph. I don't know.
Wait.
Geometry looks hard.
Katie, can I borrow one of your markers?
Highlighted.
Well, it doesn't work well, but what color? Pink and yellow. I don't want a pink and yellow.
Alright.
It does say 3. Hmm.
I got, it said like 1.2, 1.3, 1.7.
Uh-huh.
It's like next to 3 was like graph and 7 was like root.
Uh-huh.
But I don't know what 7 is.
So you will after we do number 2.
Wait, I went golfing the other day.
Okay,
I'm like, what?
let's focus. Let's focus,
I'm getting my
girls.
book.
All right. Number 2. I'm going to read it for you. Listen carefully. Number 2. It talks about the Pythagorean theorem. Remember when we talked about the Pythagorean theorem?
Yes.
What?
And it was for right triangles.
Oh yeah, A squared equals B squared.
A squared plus B squared equals C squared. Yes. Yes. A squared, B squared, and C squared. All right, so the Pythagorean theorem is one of the most well-known geometric theorems in the world, and we're going to start using it every single day you're here. It is so famous that it was quoted in a movie. What? Yes! What movie? It was quoted in The Wizard of Oz. Did you guys know that?
Yes, it was Katie.
Did you know that in The Wizard of Oz, you know, like when they're all going down like the road or whatever, there's a person hanging in the background, and that's one of the actors that hung themselves on set. Cute.
Wonderful.
That is an urban legend and not true.
Yes, it is.
It's not true.
If you look in the movie, it's there.
It's not there. Okay,
It's
it's not
I
there.
watched it myself.
It
Saw
is
with
not
my
there.
own eyes. Oh, two eyes.
All right, so it is in The Wizard of Oz, only it's not really.
He's wrong.
He's wrong, you're right. And so I just so happen to have
The clip.
the clip.
How would I use that?
Whoa.
Whoa.
So I'm gonna share, here is the part where the wizard grants a diploma to the scarecrow because the scarecrow thought he didn't have a brain. And so
Now he does have a brain.
now he does have
How
a
can I ever
brain.
thank you enough? Well, you can.
And we're gonna play it, and I want you to listen to what he says, and then I'll back it up, and we'll turn subtitles, yeah, whatever those are called, CC titles on, so you can get it. Because the question wants you to write down in math, what does the scarecrow say? And then in math, what does the Pythagorean theorem say? How are they different? Okay, so let's listen to what he says.
Back where I come from, we have universities, seats of great learning, where men go to become great thinkers. And when they come out, they think deep thoughts, and with no more brains than you have. But they have one thing you haven't got, a diploma. Therefore, by virtue of the authority vested in me by the Universitatis Comitiatum e Pluribus Unum, I hereby confer upon you the honorary degree of THD. THD? That's Doctor of Thinkology. Sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side.
Did you hear that?
So the quadrangle of the square root of the remaining side.
Doctor of Thinkology. Sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side.
Isosceles and two sides of the triangle.
Something about a isosceles triangle.
Isosceles triangle, yeah, Blake. The sum of the square roots.
Did they just write random math terms and make it into a sentence?
E Pluribus Unum, I hereby confer upon you the honorary degree of THD. THD? That's Doctor of Thinkology. Sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side. Oh, John, that's I got a brick.
I can't even read that fast.
This is sounding like slow motion.
2x times speed.
Let's see what he sounds like at half speed.
Ecology. Sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side.
Some of
The sum, now the caption reads sum, S-O-M-E, but he's saying the sum, S-U-M, the sum of the square roots,
of the other two sides of the isosceles triangle equals to the other side.
the square root of the remaining side. So he's got some problems there. First of all, what kind of triangle is he talking about?
Isosceles.
And what kind of triangle are we talking about?
Right triangle.
A right triangle, yeah. So he's talking about isosceles and we're talking about a right triangle. And then his numbers, he's doing what to them? He's not, in the Pythagorean theorem, we use the squares, right? A squared, B squared, C squared,
Area of the square whose side is the
hypotenuse.
is equal to the sum of the areas of the squares on the other side.
Right. But he's saying square root.
He's wrong.
He's very wrong. So he's taking the square root of the sides and adding them together. So if we did that as, we'd be wrong. If we did that as an equation, it wouldn't be a squared plus b squared. It would be square root of a plus square root of b equals square root of c of an isosceles triangle. But the Pythagorean theorem says a squared plus b squared equals c squared of a right triangle. So I think, do you think they did that on purpose, or do you think they were just wrong when they wrote it?
I think they like this.
I think that they didn't mean for it to be wrong.
I
And
think
just
they
say
thought that you wouldn't notice.
Yeah.
Yeah?
Or maybe like, because I feel like there's a bunch of like hidden messages in there. So like maybe like they purposely like, but like purposely.
Because he thinks he's smart, but he's not actually smart.
Yeah.
Yeah.
You know, but like not everyone does.
It's true. I don't think everybody in the world who watches The Wizard of Oz thinks it's right or wrong. I don't know.
I forgot I was on camera.
Silly goose. Okay, so that's 1.2. You've already got one homework problem down.
Wait, what? What
I
problem?
wrote it down earlier.
I'm confused.
1.2.
It's just to write down what the scarecrow
What
says.
does paper look like? Which
And
one
then
are we
what
doing?
the
One, 1.2.
I'm choosing you a little cute.
Keep going in your book until you get to the page that says 1. Keep going. Keep going. Okay,
Miss Edwards, we should decorate our notebooks.
well,
Wait, so what do we write for?
we write down what the scarecrow says versus what the real Pythagorean theorem says.
Okay, y'all should help me. I didn't know we were supposed to be writing this down.
Okay, I have another problem that I need to share with you because it's a problem that we do a lot.
What is the question? What did you say for number 2 page?
In your book?
I said what the scarecrow said and what it actually is.
For homework. What question?
Page 1
Page 1.
in your notebook, I mean in your workbook.
Wait, what did the scarecrow say?
He said.
In your workbook, there's like 8 pages that say like VII, and then there's one that says page 1.
So wait, can you replay the video again?
It's page 1, number 2.
Oh, just number 2?
Yeah, that was the scarecrow one.
Can you replay the video again?
Uh-huh. Number 2, and then you're gonna do, you're gonna attempt to graph number 3. I don't have high hopes for that one.
Just it's on my graph.
And number 7. What I wanted to explain is that we're gonna have, each problem is gonna be worth 3 points. And if you just copy down the basics of what they tell you, there's your first point, participation. Second point is gonna be if you can take it a step further. And third point will be you getting all the way there. Now, you don't have to necessarily get the right answer to get 3 points. If you make the effort to take it somewhere, you're gonna get all 3 points. And I also award half points. So I'm gonna give you as many points as I can based on your effort and your attempt at going somewhere. All right, here we go. I'm playing again. This is the slow.
Sum of the square roots of any 2 sides of an isosceles triangle.
The sum of the square roots
The sum of the square roots
of any 2 sides of an isosceles triangle.
any.
But Megan, I want you to write it in math, not in words.
Oh, not gonna do that.
Wait, okay, the sum of the square. Wait, how do I do that?
Well, what is it saying? The sum, what's the sum? Something plus something. Mhm.
So 2 square root of x.
Yeah, like X and Y, but they're square rooted.
What is that? of any two sides of an isosceles
is equal to the square root of the remaining side.
to C.
The square root of.
Square root of C. Oh, and they said. Okay,
So
square
it's
root
x
of
plus y.
Well,
Square
he's-
root of x plus y.
Yes.
So the equation in math would be, for the scarecrow, he said it would be like, what does that equal? The other, see, I'm x, like any other variable.
Yeah, any other variable,
But
but
it's the
he's
square
saying
root.
it's the square root. Yeah.
So, what's the equation the scarecrow said?
He said,
So like, he said it was the square root, the sum of the square.
the sum of the square roots.
What's the
So a square
actual?
root plus a square root.
The actual is a squared plus b squared equals c squared.
But isn't that the same thing?
No.
No, a
Squared
square
is
root
square root.
versus a squared.
Oh. Wait,
Square root is like dividing and squared is multiplying.
he said this square, wait,
Yes.
what's the real one? Square root.
Does anyone have a cup or something?
Squared.
Squared root or square?
I'm like,
The real one is squared. A squared
Dehydrated.
plus b squared equals c squared.
Oh,
That's
so it's
Pythagorean
not
theorem.
square roots. He said it's square roots, right?
Right, he said roots. And it's not roots. Is class over?
I don't think so.
Well, then why are you bopping in here?
Get out. Leave.
no.
We don't want you here.
No, no,
I don't like.
I've got another problem to do before I'm done. And I'm recording, sorry. All right, I want to go to I'm gonna go to the whiteboard.
This is her favorite class.
E period, I tell ya.
The good old days of E period. Let me go to the whiteboard so we can take a look at problem 2.3 in your book. 2.3. So this isn't homework. This is just something I want to show you because we're going to have a lot of different problems like this one. So it's page 2, number 3.
Never mind, I actually realized I hate math.
On Canvas instead of going.
Yeah, so on Canvas there are 3 problems. One of them is 1.2, which we just did together, so yay. And then 1.3 and 1.7. I want to show you,
3 and 7 are homework on page 1, right?
yes. Number 2.3, I want us to do together. And I'm going to draw on the whiteboard.
Brain! How can
Oh, chill out.
What does class now?
2.4. Okay. For 2.4, it says find the coordinates on a plane. Just kidding. 2.3.
Oh, that's because it's.
2.3. 2 different points on the line y equals 2 are both exactly 13 units from the same point, 7, 14. Draw a picture and then find the coordinates of this point. So use your notebook, and I highly recommend that when you use your notebook, you're using those lines in your notebook for the actual graph. So count over
If it's just y equals 2, does that mean it's vertical or horizontal?
horizontal, because no matter what x is, forward or backward, you only go up 2. So if I'm going to put in here an x and y axis, I highly recommend you label your X and Y axis.
Coordinates just 0, 2.
Well, 0, 2, 1, 2, 8, 2.
Oh, all of them
Yes. So the line Y equals 2.
of the 13 units.
The line Y equals 2 has all of the points on it where Y equals 2. So 0, 2, 1, 2, 5, 2, 7, 2. That's how you know for sure. And I will have my iPad and stylus set up soon, but for now I'm drawing with a mouse and it sticks. Oh, wait a minute.
Miss Edwards,
Yes,
did you know that I look forward to class?
that makes me happy. All right, and here's my line. Y equals 2.
Is it pretty strictly?
It is in April.
It's supposed to be 13.
It's at the end of the month.
Is it April 27th?
It's April 30th. The very end. All right, so our line Y equals 2 is a horizontal line because Y equals 2 no matter what the X is.
Does he have like a touchpad or something? Like the people at Khan Academy? Like, do they
Yeah, he has a touchpad. I could do this on my laptop, but I can't I can't get it on the overhead from my laptop. So I will be able to put the iPad to the overhead and then I'll be able to write on it. And I won't look like a freak. Okay, so I've got my x-axis, my y-axis. Here's my line, y equals 2. And then it says I've got a point 714. So this is where, you guys, it's important for you to really count off like over 7 and up 14. And don't like try to count 5 spaces in one box on your graph paper. Really use one box to mean 1.
Oh, 14, you know what? Can I go? Can I just like guesstimate 14? Because if I do it by the square, like goes up 2.
Yeah, so just put it up as high as you can. We're going to call this a sketchy sketch. This is page 2, number 3. Yeah.
This one's not.
This is not homework. This is in-class work. I highly recommend, though, that you guys do put in the problem number. So make sure you've got 2.3 written down, circle it or highlight it or write it in a different pen color so that it's easy to find. Because when we do a test, I will tell you there is a problem on the test that's exactly like problem 2.3. And when you get to that problem on the test, you're going to want to come back to this problem and look at it.
Are we allowed to use our notebooks for a test?
Yes. Okay, so it says that there are 2 different points on this line y equals 2 that are 13 units from this point, 714. So I don't know where those points are, but they're 13 units away. So I'm just gonna like put them out here. Like I don't know.
Does this make me a triangle?
Well, it said that they're 13 units away. So from here to here has to be 13. And from here to here has to be 13. And this, whoops, this point right here
from the point y minus 2 to 7.
So it doesn't matter, like, if
It's supposed to be 13.
it doesn't matter what point it is, it just has to be 13.
Right. It could, maybe it's like really skinny down to here, or maybe it's like goes way out there. I don't know. All I know is that it's 13. Wherever it is, it's 13. So did I do what it said? 2 different points on the line. I do have different points there. I have the line y equals 2. I've got 13 units from 714, and I drew a picture of it. So I've got the basics down. Now it says find the coordinates. It wants us to find what's this point right here, and what's this point right here.
About 1 and 2.
So you'll hear me say this every day for the rest of your life. Where's the triangle? And not just where's the triangle, where's the right triangle? Can we draw lines that get us right triangles so that we can start using the Pythagorean theorem to find the length of the side or the hypotenuse?
Is there like you go up from
So it'd be like the points.
like anyways. So like you have the graph and then you can
You could go that way, yep.
You're supposed to. So it's like
My line is totally not straight, sorry. But yes, you could go here.
can you go like to that way too?
Yep. They'd be exactly the same lengths as the other one. So you could go that way. What's another way we could go?
You like
You're not going to be able to know the diagonal measurement.
How does this go like that?
From where to where?
what if you did this and then also this?
You can't know a diagonal measurement.
But it'd be like the same height since
Oh, parallel, you mean?
I don't know.
it's the
We can do it the way you've got it, Megan. So if I was looking at this triangle, where would the right angle be?
at the top.
At the top, yeah. This is a right angle. So then this length of 13 on this blue line, this is part of the right triangle. What part is it? Is it a leg or is it a hypotenuse?
Which part?
This blue leg, this blue part.
Leg.
Is it a leg or hypotenuse?
Leg. Because you said it's blue leg.
I did say it was a blue leg, but that was intentionally misleading.
Was it a hypotenuse?
It's across from the right angle, so it's a hypotenuse.
Oh, that was close.
So we've got a hypotenuse here. But we have to have another portion, right? We've got a squared plus b squared equals c squared. We have to have we have to have two parts of a triangle to solve for the third one. So what other measurement do we have? We have to either have this leg or this leg. Which one? The up and down one? Yeah. How do we know what that measurement is? By counting, yeah. This is the y value, right? It's up and down. What's my y value at the very top? How far up have I gone here?
7.
Nope, 7 is the x.
Oh, 14.
14. And so from here to here, what's my y value here?
14. Oh, from where?
Right here. What's this line?
That's 7.
Sorry, I wrote on it.
From the.
So here, the y value is 14. Here, the y value is what? How far up have we gone?
Oh, 2.
Yeah. So then this distance must be between 14 and 2.
Oh, 16. Oh, no.
The difference.
12.
Yep. So now I know the hypotenuse. That's 13 squared. Sorry for the crazy. 12 squared plus, we'll call it a squared. God knows I probably can't write it b at this point. Right? If this is a. So 13 squared, the hypotenuse squared equals one side squared plus the other side squared. So if we do this math, 169 equals 144 plus a squared so 169 minus 144. So if a squared is 25, what's a? 5. Yeah. A is 5. So we also could have done the same thing by just dropping a line right here.
Wait. What? Oh. That makes sense.
Because what we have right here now is this distance right here is 5.
Where'd you get like 25?
169 minus
Oh,
144.
wait, never mind.
So now this distance is 5. Do we know what this point is right here? How far over is it? X. 7. How far up is it? 2. And so I need to know, how much, if I'm going over 5 more, then the y doesn't change, right? That is school over. I just add 5 on. Oops, just kidding. That stays 2, and that's a 14. I'm adding, just kidding, that's a 12. I'm adding 5 to the 7. Here I'm going to subtract 5 from the 7. And you can see that our point actually is 2, 2 on the left. And my sketch is wrong. My left-hand point does not go into the negative. So we'll have a lot of problems like this, and we'll work a lot of them in class, but you'll have some for homework as well. Thanks, Blake, for hanging in there.
Wait, Blake. Where is he? Blake,
No problem.
Blake, are you
Yeah.
at school tomorrow in study center?
Yeah, probably. I'll probably be there.
Okay, help you feel better.
Yeah, Yeah. I just left my backpack. I feel fine.
Feel
Thank you.
better. I think she's trying to start a rumor, Blake.
Yeah, I know.
Thanks for coming to
All
class.
right. See you in Edwards. Have a good day.
Bye.
Bye.
I just think my